Good morning, students. Chapter 7, System of Particles and Rotational Motion. In last lecture we have discussed about rotational motion, axis of rotation, angular position, angular displacement. Now today we will see some next quantities: angular speed, angular velocity. Okay, see again I will draw that case. See here it is x, y, origin. Okay, x axis, y axis, z axis is perpendicular to body coming outside. One object, one rigid body, it is like this. It's 1 point, it is at p, at time t is equal to 0. So yes, connect this point with center, connect this point with center. It makes some angle with x axis and it is called its angular position, that is theta. Yes, yes it is. Okay, then if this rigid body is performing rotational motion in this direction, then after some time, that rigid body will be like this. That rigid body will be like this at this point. Okay, so yes, this point P, which is initially at this point. Okay, after some rotational motion, it will be here at point P dash. At time t is equal to t. At time t is equal to t. And now, what is its angular position? Connect this point with center. Connect this point with center. Okay, so its angular position will be it is theta plus delta theta. Its angular position will be it is theta plus delta theta. So yes, here I will write it again. At time t is equal to 0. At time t is equal to 0. At point P. What is angular position? Yes, angular position is theta. Okay, similarly at time t is equal to t, that is at point P dash, at point P dash, angular position is, yes, angular position is theta plus delta theta. Okay, so therefore in time interval delta t, angular displacement in time delta t, angular displacement is equal to final angular position is theta plus delta theta minus initial angular position is theta. So theta minus theta, it will be, it is delta theta. So in time interval delta t, angular displacement is delta theta, and from this we will define angular speed. What is angular speed? Angular speed. Okay, angular speed is defined as, then yes, first of all we will define average angular speed. Average angular speed, it is defined as ratio of angular displacement and time. Now, why we have to study angular speed? Angular speed means how fast it is rotating. Simple. How fast it is rotating. Yes, if fan is rotating, then how fast it is rotating. Earth is revolving around sun. Earth is also revolving around its own axis. Then how fast it is moving. So it is angular speed. It is its angular speed. So yes, it is defined as ratio of angular displacement and time. How to indicate this average angular speed? What is its equation? Its equation is average angular speed is equal to angular displacement upon time. Okay, average angular speed is denoted by omega and it is symbol of average, is equal to angular displacement delta theta, time interval, here it is delta t. So omega is equal to delta theta upon delta t. It is average. What is limitations of average? Yes, it will give average value, it will not give instantaneous value. And we know that if delta t tends to 0, yes, we have discussed about this point. Okay, if delta t tends to 0, then average value it becomes instantaneous value. It becomes instantaneous value. Okay, so yes, if I am taking delta t tends to 0, then average value is equal to instantaneous value, and therefore instantaneous angular speed at time t omega is equal to limit delta t tends to 0 delta theta upon delta t. So therefore omega is equal to it is d theta upon dt. This equation of instantaneous speed, omega is equal to it is d theta upon dt. Angular speed is equal to angular displacement upon time. What is its unit? Yes, what is its unit? Its unit d theta angular displacement. Its SI unit is radian divided by dt. It is time. So its SI unit is second. So what is unit of angular speed? It is radian per second. Yes, it is radian per second. Now, what about angular velocity? It's all about angular speed. What about angular velocity? If we link proper direction, with angular speed, it becomes angular velocity. It becomes angular velocity. Clear about this? So yes, magnitude so you have to find with the help of this equation. Magnitude you have to find with help of this equation. But if you link proper direction with angular with speed, then it will give angular velocity. It will give angular velocity. Clear? So it's about angular speed, angular velocity. How to find its magnitude? So yes, magnitude of angular velocity. Magnitude of angular velocity. Magnitude of angular velocity. Omega is equal to it is d theta upon dt. Yes, it is d theta upon dt. Now, how to find direction of angular velocity? That is most IMP question and it is most IMP thing. Okay, see. How to find direction of angular velocity? How to find direction of angular velocity? See, we will find direction with the help of one example. Let you have one disk like this. If you have one disk like this, about this axis, it is rotating in this direction. Do you understand? It is one disk, okay, and about vertical axis it is rotating. For example, yes, it is disk like this, okay. this disc is actually like this, and it is rotating in this plane, and it is rotating in this plane, and it is rotating in this plane. Clear about this? Yes or no? Yes, it is rotating in this plane. Okay? So see, what is method? What is method? How to find direction of angular velocity with the help of right hand screw rule. Okay? Right hand screw rule method. Okay, how to find right hand screw rule method? First step, hold screw in right hand parallel to axis of rotation. Okay, so yes, in right hand you have to hold screw parallel to axis of rotation. Axis of rotation is vertical, so you have to hold screw in right hand parallel to its axis. Okay, I will draw here this. Okay, let it is screw. Okay, yes, it is screw. It is parallel to this axis of rotation. It is axis of rotation. So yes, it is axis of rotation. So hold screw in right hand parallel to axis of rotation. Second step is rotate screw in direction of rotation of object. Object is rotating in this direction. Yes or no? So you have to rotate screw in this direction. Yes, you have to rotate screw in this direction. Yes or no? You have to rotate screw in this direction. So yes, if you rotate screw in this direction, means it is in anti-clockwise direction. We know that this screw will advance in upward direction. It is advancement of screw. Screw will advance in this direction. Yes or no? Yes. Then see, hold screw in right hand parallel to axis of rotation. Rotate screw in direction of rotation of object. Direction of advancement of screw. Gives direction of angular velocity. It gives direction of angular velocity. Clear about this? So yes, it is how to find direction of angular velocity. Simple. Okay, hold screw parallel to axis of rotation, then rotate screw in manner in which object is rotating. Then advancement of screw gives direction of angular velocity. Yes, it is right hand screw rule method. Yes, we can also use another method, that is only right hand method. And it is easy. See how easy. Yes, this object is rotating in this direction like this. So what is method? Wrap fingers of right hand in direction of rotation of object. Thumb indicates direction of angular velocity. So simple. If object is rotating in this direction, this thumb indicates direction of angular velocity. So yes, this angular velocity, it is in this direction. It is normal to plane of disc upward. Clear about this? Yes, if it is rotating in opposite direction, then if it is rotating in opposite direction, angular velocity will be in downward direction. Again, what is another method? Wrap fingers of right hand in direction of rotation of object. Thumb indicates direction of angular velocity. Clear about this? So yes, it is how to find direction of angular velocity. Okay, now we will see next topic, that is angular acceleration. Now next topic is angular acceleration. Yes, angular position, angle made by point with x-axis. Angular displacement, change in angular position, it is called angular displacement. Angular speed, how fast object is rotating. Now what is angular acceleration? Yes, angular acceleration. See, let at time t is equal to t1, angular velocity of particle is omega, and at time t is equal to t2, angular velocity of particle is omega. Then yes, how to define? First of all, we will define average angular acceleration. Average angular acceleration. Average angular acceleration is defined as ratio of change in angular velocity, change in angular velocity divided by time, divided by time. Average angular acceleration is equal to change in angular velocity upon time. How to indicate angular acceleration? It is indicated by alpha. So alpha is equal to, it is change in angular velocity, delta omega, upon here it is delta. Upon here it is delta t. Clear? So yes, it is average value. How to convert in instantaneous value? If delta t tends to 0, then instantaneous angular acceleration, alpha is equal to, it is d omega upon dt. It is d omega upon dt. And yes, this angular acceleration is vector quantity. Angular acceleration is vector quantity, and its direction is in direction of change in angular velocity. Just this point you have to remember. Okay, what is direction of angular acceleration? It is in direction of change in angular velocity. Now, instantaneous angular acceleration, it is d omega upon dt. So it's SI unit. Omega, its SI unit is radian per second divided by time. So it is second. So its unit is radian per second square. Yes, its unit is radian per second square. Okay. Now, angular acceleration is in direction of changing angular velocity. But if axis of rotation is fixed, if axis of rotation is fixed, then acceleration is parallel to velocity. Acceleration is parallel to velocity. Yes, average acceleration is parallel to velocity. For example, if we have one object like this, one disk like this, okay? Yes, it is one disk like this, and it is rotating, in this direction. Okay, then again, chalo, how to find direction of angular velocity? Object is rotating like this. The thumb is in upward direction, so angular velocity, it is in upward direction, and also direction of alpha. If this axis of rotation is fixed. Clear about this? So yes, it's all about angular acceleration. It's all about angular acceleration. So yes, in today's topic we have discussed about what is angular speed, angular velocity and angular acceleration. Most important thing is direction of angular velocity and angular acceleration. Okay, now if this disk is rotating, for example, if this disk is rotating in downward in this direction, for example, if this disk is rotating like this in this direction, okay, then what is direction of angular velocity? Then what is direction of angular velocity? That you have to write your answer. Clear? So yes, it's all about angular acceleration, and yes, for today this is it.